Hey, this is Mr. Ariel. I'm here today with a video about atomic basics. Now, you may have learned some of this material in a previous class, but take good notes anyway, and keep your eyes peeled for details that you may have forgotten, or some things you didn't already know. Let's go ahead and get started. So on my first slide, I don't need you to write anything down. I just like to make a comparison about the size of atoms in general. If you wanted to build a model that could show you the individual atoms in, say, the peel of an orange, you'd have to enlarge the orange to be the size of the Earth. Even then, the atoms that make up the orange peel would be the size of marbles, and they would cover the entire surface of the Earth. Now again, you don't need to write anything about that. I was just making the point that atoms are incredibly, fantastically small. Now, before your attention span gets any smaller, let's move on. Now on this slide, I need to show you about the three types of subatomic particles. Subatomic, that just means smaller than an atom. So these are the particles that make up atoms. First up, I've set up a table over here. You should probably copy it into your notes and we'll fill it in here today. There are three types of subatomic particles, and they're protons, neutrons, and electrons. Now again, if this material you already knew from a previous class, enjoy that part of class while it lasts. But take good notes as practice for later on when we're in totally new territory for you. Now you need to know the location of each particle, its mass, and its charge. Protons and neutrons are located in an atom's nucleus. That's another word for the middle of an atom, and I've got it drawn right over here. And so now I'm going to put some protons in. I'm going to put in, I think, 3 protons. There we go. And I'm going to add a couple of neutrons just like this. All right, so I put in 4 neutrons and 3 protons. Now for the mass of these two, protons and neutrons, we say that they're one atomic mass unit. That's abbreviated as AMU. They really do have a mass, but it's actually 1.7 times 10 to the negative 27th kilograms. That's a complicated detail to remember, and the thing is, it's not even really relevant to much of anything in chemistry. And so we just simplify that detail and say that protons and neutrons have a mass of 1 atomic mass unit. Sometimes you might even see AMU abbreviated as just plain U. Like my nucleus right here has 4 neutrons and 3 protons, so its atomic mass would be 7U, or 7AMU. Now we'll learn some more about atomic mass units in another lesson, but for now, let's get back to subatomic particles. Now finishing up with the charges on protons and neutrons, protons are positively charged, so I say +1 here, while neutrons have no charge. That's why there's a 0 there. They're called neutrons because they're neutral. Now finishing up with electrons, they're located in the electron cloud. So I drew that in, and the electron cloud is just a region where the electrons are found, and it's outside the nucleus. So I'm going to drag in some electrons now. I've got 4 protons, so I need 4 electrons in my electron cloud. All right, now I've got all 4. And these electrons are really actually going in all directions. They're kind of flying around the nucleus and making a big sphere, and we'll learn a lot more about that later this year. Now, I knew to put 4 electrons in the electron cloud. You can abbreviate that as 4E negative. I knew to put them there because we had 4 positive protons. So if you think about it like this, protons we know are positive, and then electrons are negative, so if we subtract them, we end up with no charge. Or in other words, it's neutral. Unless you're told otherwise, atoms are assumed to be neutral. Now there's a lot more to learn about the structure of electron clouds, but we're going to save that for a later unit. Right now, if you know that electrons orbit the nucleus in the electron cloud, and you know that they have a charge of -1, the last thing we need to get is the mass, and that happens to be 0. That's not really entirely true. Electrons have a mass, an actual mass of 9.1 times 10 to the negative 31st kilograms, and that is incredibly small. That's about 1,800 times smaller than a proton. So if we simplified the mass of a proton and we just said it was 1 atomic mass unit, well, the mass of an electron is then really close to 0. And in chemistry, the mass of an electron isn't really relevant to anything we need to learn about. So we just say it's 0, and that's it. Now, moving on. Here on this slide, we need to get a few notes about basic atomic math. Basically, we need to be able to figure out the number of protons, neutrons, and electrons in any atom that we're dealing with. Now, I've got a small table set up down here. You can go ahead and copy it in, and then we'll fill it in as we go. Now the first idea we need to get here is that every element has an atomic number, and it's set as the number of protons in the nucleus of an atom. Again, you probably already knew that, but get notes on it anyway and enjoy these easier parts of class. You'll get to use a periodic table in class for anything where you need to know an atomic number because it's printed right up here on the top of every element. Like this is mercury, and it has 80 protons because that's its atomic number. So we can go ahead and fill in on our table that mercury-200 has 80 protons. Now about this 200 here and this 202 over there, we'll get to that in just a minute. Now the next thing we need to pick up is that all atoms of the same element have the same number of protons. So by the symbol here on Hg202, it's mercury. So that means it has 80 protons, just like mercury-200. As for the number of electrons, that's going to be equal to the number of protons. So that's 80 for both atoms. Remember, the number of protons minus the number of electrons right now is always going to work out to be 0. In a later unit, we're going to learn about charged atoms. They're called ions. But for right now, we're just dealing with these neutral atoms. And so that final charge has to work out to be 0. Now, last up, we got to figure out the number of neutrons. That number is not on the periodic table itself. The atomic number will not give us that information. But you can use the atomic number to help figure out the number of neutrons. Now, an atom's mass is equal to the number of protons plus the number of neutrons in its nucleus. So for this mercury-200, that 200 is the mass. And the same thing for 202. And so if mercury-200 has a mass of 200, and that's protons plus neutrons, well, we can just subtract off the protons, and that's going to leave us with 120 neutrons. So I'll fill that in here. Now we can do the same math for mercury-202. That'd be 202 is the mass minus 80 protons, and that just works out to be 122 neutrons. So I'll put 122. Now that brings us to the last couple of things we need to learn today. Isotopes are atoms of the same element. I mean, they have the same number of protons, but they just have a different number of neutrons. So these two atoms, mercury-200 and 202, these guys are isotopes of mercury. They're both mercury, they just have different masses due to having a different number of neutrons. Now the last thing, if you see on the periodic table here, it says that the average atomic mass of mercury is 200.59. Well, how does the average of 200 and 202 work out to be this? It's not really quite that simple. I'm going to teach you this in a different lesson, but for now, just look at this list. It's all of the isotopes of mercury. There are quite a few, and this column right here shows how abundant each one is in nature. So the average mass of mercury is 200.59 because it's a weighted average. It takes into account how abundant some isotopes are, while others are quite rare. Now you don't really need to write anything about that into your notes for now, we'll get that later. Let's move on to the last thing. Now I promise this is the last thing to get into your notes, but if you need to figure out the number of neutrons in an atom and you have a mass number kind of written like these down here, well, you use that number right there as the mass number. But if you see it written like this, like number of neutrons in mercury atoms, well, you've got to use this average to start with. So we're going to start with 200.59, and then we round it to the nearest whole number. So that's going to be 201, simply because the 5 makes us round up to 201. So that's 201 protons plus neutrons, and we're still going to subtract off those 80 protons from the atomic number. And so that works out to be 121 neutrons in the average atom of mercury. So just get that detail into your notes that if you have a mass number like these over here, you use it and subtract off protons. But if all the information you have right here is just its mercury, just get in your notes that you need to round that periodic table mass and then subtract, and you're all set. Now, if you got all that into your notes, you're all set for this lesson. So I hope the video was helpful to you today. And as always, thanks for watching.